Let's begin our session. Yes, yesterday, let me just brief you for 5 minutes what happened. Let's just recap what happened yesterday. Yes, now let me just show you this. And yesterday we had added this load combinations. We have added this load combinations, and then we added this load list, and then perform analysis, and then load list. We also have added this design parameters to this structure. We also have added this design parameters to this structure, right? So here we have a design parameters. Let's go to design, and then here we have a concrete. Then we have to then change this code book IS 456-2000, and here we have a selector parameters. So we went to this selector parameters, and then we started choosing the required parameters. See, some of the people had asked yesterday to add this clear cover to members and so on. So we did not intentionally consider them, because if I can go to this, I can just show you once again. If I take this only compressive strength of concrete and then yield strength, I can say okay to it. See here what is happening. I'll go to this defined parameter, but when I just check this default values for this grade of concrete and the grade of steel, so these are not in fact practicable. So the grade of concrete which is chosen by this staad pro is 27.5 something else, which is not the case. I mean, which is not the grade of concrete available in IS 456. So that is the main objective for choosing only grade of concrete and then grade of steel and then torsion. All right. Remaining parameters, it doesn't mean that staad will not consider or we are skipping them. Staad will automatically consider the remaining parameters, right? So see, FI, FCK has the same problem, even for the FI also. So in the case of FI, if you can just see this value 413, something else is given. It's not even 415, right? So whatever the grade of concrete and the grade of steel chosen by the staad pro by default would not be available practically. So that is why we used to take this FI and FCK values. I mean, we have to consider those FCK and FI values and assign those grades of materials to this structure. The remaining parameters which are there in the selector parameters, are in fact are considered by this staad pro automatically, right? Automatically. That's why we did not change the remaining, or we did not consider this remaining parameters in the design cases. In the design case, right? I'm going to just close it. So once we could select the parameters, those parameters have to be defined here. And then once we could define the parameters, then we have to go to this commands option. We have to now go to this commands option. Then I can add design beam and the design column and then takeoff also. Of course, we did not talk about this takeoff yesterday. Today we will be talking about this takeoff also. So design beam and then design column, right? And design slab or element is mentioned. However, we don't design the slab. With the staad pro. Right, the last one is takeoff. So once we could add this design beam, design column, and then go to this, close this, and then those parameters are added here. Now you have to add these parameters. You have to select all these parameters and apply or assign those parameters appropriately to this structure. Like FCK grade of concrete for all components, and then FI main, and then FI secondary, and then torsion on one on, and then ENSH enhanced shear strength, and then design beam, and then design again beam, and then this is a design beam, and this is a design beam, and then this is a design column, and then this is a concrete take, and then end the concrete design. So once you can notice, if you can just observe here, all these are tagged with the green color one. It means all these design parameters are assigned to this structure. Parameters are assigned to this structure. So once we had assigned all these properties, then design parameters to this structure, then we went back to this analyze. So for running the analysis, we have two shortcut keys. One is Control plus F5, and the second one is F9. So either of those options we can use them for running the analysis. Once we run the analysis, we could identify 626 warnings. We could identify this as 625 warnings, and then we went back to this. Staad output. We went back to this staad output. Here it is, right? We went back to this staad output, and then we just had clicked on these warnings and the errors. And of course, fortunately, we were not having any kind of errors, but we had warnings. So we went through all this type of warnings, and there are four types of warnings available in this staad output file. And the first one, which is in fact not so design point of view, so that is enhanced shear strength, which means when I have a member length, I mean length to depth ratio is less than or equal to 2.5 times. Usually that definition is applicable only for the deep beam cases. That definition is applicable only for the deep beam cases. So that is what actually staad also has mentioned in this output file, saying that so this is a deep beam and staad has not considered as a deep beam for designing it. Such kind of the information was displayed with this staad output file only. So what we did is we have noted all those member numbers like this. See this. So there are few still, I mean, there are few more members like 3726 and then 3910 and then 3929. So here I still have a 3 more member numbers. So once we could note all these member numbers, then we went back to this Word file and we mentioned like ENSH, enhancer shear strength 1, and then MB memb and then space, and whatever we have listed out the member numbers, those numbers have to be mentioned in the separate file, and copy all those member numbers and then go to this staad input editor, then go to this staad input editor, and then go to this staad input editor. So then we have to, we have to just add, we have to add that statement before beam design, See, I'm just scrolling this down, extreme down. Here I have a beam design beam. So before this beam design, I have to add this enhancer shear strength numbers, enhancer shear strength 1, and then so on, so member numbers. And of course, we also have noticed that there are 3 more member numbers which were left yesterday. Now I'm going to take those member numbers also. What are those member numbers? We just note them. So one is, yes, here I have 3726. So I'm going to add here. 37. I can say 3726 dash and then 3910 and then 3929. Did we miss any other member numbers with the same warning? No, we did not. I'm going to close this. I'm going to once again close this. Yes, I'm going to close this also. Right? Now done. Now we almost have 523 warnings, and it is sure, and we are sure that most of those members are columns only, because as we know that we did not in fact give any kind of appropriate column sizes to this structure. We just have assumed a kind of a property like 300 by 600, and then we started running the analysis, because first we need to run the analysis. What we are saying is a very pure technical way for finalizing the column sections or column sizes, right? So we just have to assume some kind of a column size and then run the analysis. And once you run the analysis, then you have to find out the amount of the loads that are transferring to the columns, You have to take those loads from the staad pro and keep these loads in a separate Excel file and find out the maximum and the minimum column loads. And then based on this minimum column sizes, with respect to its capacities, we can just group the column sizes. That we are now going to discuss. Right? So what I do is, before I'm going to freeze the column sizes now, I'll go to this front view. I'm using this nodal cursor. I'll go to bottommost nodes. I go to this bottommost nodes. I'm using, I can say right click, new view, okay. I go to this plan view. So there are all the supports. I wanted to turn off the supports, shift plus yes. For the turning off supports, shift plus yes. Turning on, turning off, right? I turn on this supports and I wanted to turn on this nodes, for which I must be mentioning shift plus N. Shift plus K for nodes display, shift plus K for nodes display, and for node numbers I must be pressing on shift plus N. So these are the node numbers. These are all the node numbers. But when you notice these node numbers are having a different numbering like 70, 71, 72, something else, so on. But I wanted to have a numbering like 1, 2, 3, 4, 5, 6, so on, so next direction, and then Z direction 1, 2, 3, 4, right? See, I can say it's 1, 2, 3, 4, something. Here I can say 84. I can say 84. Sorry, here I can say 14, number 14, and then 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, something it might be 70. It might be 70, right? So this is how I wanted to have a numbering to this foundation. I mean to this bottommost nodes or to the foundation, so that it will be easy for us when we are reading the loads to the respective nodes or to the respective foundations, right? So what I do is now I need to renumber it. I need to now renumber it, right? I'm going to see this whole structure again. I'm going to select this whole structure, right? I wanted to renumber on foundation level. However, I'm selecting all these nodes. I'm selecting all these nodes. I go to this geometry, renumber nodes. Can you please take a screenshot? Geometry, renumber nodes. Can you all please take a screenshot? Geometry, renumber nodes. Geometry, renumber nodes. I can say yes. Now I wanted to have a numbering like 1, 2, 3, 4. Means which direction is this? X direction. I can say 1, 2, 3, 4. Which direction is this? X direction. And then once I could finish in the X direction, maybe around 10 or 14, whatever it is, up to 14. Now I wanted to start numbering maybe at the same level only, foundation level, like 15, 16, 17. So once I could renumber in the X direction, next line is this one, this direction. What is this direction? Z direction. So what is the third direction which is left? That is Y direction, right? So X, Z, and then Y. Exactly opposite to this, I need to give renumbering like Y, Z, and then X, right? Y, Z, X, Z, Y, Y, Z, X, right? So what I do is Y, Z, X. So I'm going to start the renumbering with number 1, numeric number 1. I say accept it. Okay. Yes, now I'll go to this front view. I'll go to this front view. Let me take only bottommost nodes because bottommost nodes are more important for us as those are the foundations, I'm going to say Alt VV or right click new view, whatever it is. Alt plus VV is a shortcut key or otherwise right click new view, right? Now I go to this plan view and now can you just look at this numbering? 1, 2, 3, 4, something 14, 15, 16, something else, and then finally 70. So whatever we notice the last number, last bottommost right bottommost corner numbering would be indicating the number of foundations or number of columns. So how many columns we have in this structure? It is easy to recognize that we have 70 number of columns. We have 70 number of columns in this structure. We have 70 number of columns in this structure. So that is how first we have to renumber the nodes. Similarly, we can even renumber the member numbers, but we don't do it right now. Now let's run the analysis. I go to this run analyze. I can click here, or otherwise I can use the shortcut key Control plus F5 or F9. So anyway, time being, I'm using the same command from the menu bar. Click it. Last time we had around I think 506 somewhere, 506 or some warnings. And out of this 506, I think we are still expecting 3 more warnings to be reduced because we had again added this this LYD ratio warning, LYD ratio or D-beam warnings. Now it's a running analysis, let it be. See how much time staad is taking for performing the analysis of 10 floors building, 10 floors commercial building with various combinations. It is hardly taking only, it's hardly taking 2 to 3 minutes. See, it is still running the analysis. Now how many warnings we have? 501. I think there is a soap name on this 501. See, we have got 501 warnings now. We have now got 501 warnings, right? Okay, now I can say done. I can say done here, right? Now what I want is I wanted to see the reactions or the loads that are transferring to the columns, right? If I want to see the reactions, I have a two options. The first one is I can directly find out, or I can see the reactions directly on this window. First way, and the second way is I can even get those reactions in the form of tables, in the form of a table of contents, right? I can say in the form of tables, right? So I have two ways. Now let's first go to this one. I wanted to see these reactions, so I go to this staad. Here I have, so I go to this post processing first. Let's go to this post process, click on it. I can say okay, maximize it, and here I have reactions icon. Once I click on this reactions icon, the reactions will be displayed in the same window. However, since we have n number of columns or n number of foundations in this window, it would be very difficult, or it is it looks very clumsy to recognize those values. However, let's show you some of the reactions here. I can just click on these reactions. I can maximize it. See, once I can see, once I click on this, I'm getting the displayed reactions for all the columns. I can of course adjust this reactions table also. I can adjust this reactions from here by clicking this icon. Can you just look at this icon? Here I have an icon. Here I have an icon. It's like a A. It is looking like a A symbol. I have to click on it. I can click any one of them, keep them right side. And I can click any one of them, keep them like this. Click anything, right like this. I can keep like this. I can drag some more like this. See here. I can drag like this. See, and I can take all this. Sorry, I can take all these reactions separately from here. However, it is still difficult to recognize the reactions. So that is why it is more advisable to just take few of the nodes or few of the foundations for knowing the reactions. So what I do is I'm going to use nodal cursor. I'm going to use this nodal cursor. Let me select only few of the columns here or foundations. I can say Alt VV again. See, Alt VV. Now I have reduced number of foundation, number of columns and number of foundation from this view. So now I can adjust. Now I can adjust by using this same icon. I can adjust the same icon by clicking this here. See, where is that? This is here. This is somewhere. This should be somewhere here, and this should be somewhere here. So this is the left. Sorry, this is on left. This is the middle one. This is the left one, and this is here, and here it is. Yes, I can say this is here. I can say yes. This is the central one. I can have this here. I can also have, yes, this is left side. And this is here, somewhere here. It should be somewhere here. I can keep it somewhere here. See, now it's easy to keep the reactions table. It is easy to keep the reactions table separately when I have a less number of columns here. I can even just zoom in and zoom out. I can even then zoom in and then zoom out. So I can just zoom in, zoom out for this reaction. See, this is how to see these reactions. And of course, now the question is for which combination the reactions are displayed here. So that we can verify from this bar, right? I can click here and then I can click the first one. When I click here, 1.5 times the dead load plus live load, automatically automatically these reactions are changed. So these are the reactions that is for 1.5 times the dead load plus live load. When I have a 70 number of columns or 70 number of foundations in the same structure, in the same window, it is very difficult for us to read the reaction for different combinations. So you can just select a few of the a few of the nodes or a few of the columns, and then you can go through the reaction numbers, right? Just to confirm me, is this clear to all of you? Is this clear to all of you? Is this clear to all of you? Can you please post a message? Is this clear to all of you? That's great. That's great. That's great. I need responses from everybody. Please post a message. We are not designing a foundations. Please stay for some time. Yeah, renumbering of nodes. Okay, I do that. Yes, renumbering of nodes, I can do it. And I also once again will explain you the reactions. Don't just say once again, please. Let me know the clearly what you really, what you really need it. Instead of just saying repeat. Yes, we can get them. We can get them, Bakir. We can get those reactions in the tables. Yes. Now let me get back. Let me get back to all. See, I'm going to click on this modeling mode. Here I have a modeling mode. See, here I have a modeling mode. I'll go to this modeling mode. Now I'm here. So I wanted to get complete structure or whole structure, for which we know this is the icon, whole structure icon. Let's click on this icon. So now I'm here. I am in this whole structure model. Now I'm not directly going to show you this, renumbering it. Let me just show you the reactions, how we are getting, then we can again renumber it, right? So here we are. Oh, now I need to go to this post processing. I wanted to see the reactions, so I go to this post processing, right? I'll use this a front view. I wanted to see only this bottommost nodes. So let me select all the bottommost nodes. Alt VV. I go to this plan view, and these are all the nodes. These are all the renumbered nodes. These are all the renumbered nodes. 1 second, please. Okay, so here we have a nodes. Here we have nodes. We wanted to see the reactions for it. So I can go to this reactions. Here I have reactions tab. I can click on this reactions tab. See, I can maximize this, and I have found remaining. Sorry, I have found the reactions for all the nodes, or I can say all the foundations, right? If I want to see them, or if I want to keep them in a separate way, if I want to just separate them, I can use this icon, this one. Yeah, it is looking like a yeah. Select it, and then I can keep like this, 1, 2, so on. So see, sometimes it doesn't work. See, last it worked, now it is not working. See, likewise, I need just separate them. I need to separate them. So instead of just going through this, I need to select the few of the nodes only. So for which I can select a few of the center nodes, whatever the nodes it is. If I want to see the reactions only, in the form of this table, I can select a few of the nodes, I can say Alt plus V. See, now I have all these nodes. I can now use the same icon, separate them. Now I can just separate them. Like this, I can separate them. Like this, I can separate, right? This is how to see the reactions directly in the when on this window, main window, right? If I want to change the reactions, if I want to see the reactions for other load combinations, here I have a toolbar. We have to select it and select the combination for which we need to verify the loads. See, now loads are changed. Now the loads are changed, right? So this is the way for verifying these loads. And now let's get back to this modeling and let me explaining you this renumbering. So here I wanted to get back to this modeling mode, or of course, or otherwise I can even get back to this whole structure. Here icon, here is the icon. So let's click on it. So once I click on it, so I have got all this, entire structure. Now let me select all the nodes. I'm selecting all the nodes like this. Now I have a whole structure. I have selected all these nodes. I wanted to keep the numbering. Let me say, let me select you this bottommost nodes so that it will be more convenient for you to understand. So I'm selecting this in bottommost nodes, Alt VV. I can keep it in the top view. And here it is already there like 1, 2, 3, something, so on, so on, so. Now I'm going to renumber it, like renumbering it from 100, 101, 102, something else, right? So I wanted to have a numbering like this. It is easy for me to read from left to right, right? So this is already renumbered. Sometimes what happened, those would not be in the organized numbering way. So that won't be well organized, right? So now I wanted to have a numbering like 100, 101, 102, 103, 104, something else, and then 114, and then this 115, 117, something, and then 170, right? So this, what is this? What is this direction? This direction is X direction, right? This direction is which direction? X direction. How about this direction? Z direction, right? And what is the last direction or third direction? That is Y direction. Now I wanted to renumber first on this plane, or I can say on this floor, and then I wanted to renumber the remaining nodes in the next floor. Next floor in the sense Y direction, right? X direction, Z direction, and then we have Y direction. So when we know, see here, 1, 2, 3, 4, 5, 6, which direction is this? X direction. So once I could finish numbering, once the renumbering is finished in this direction, next 15 is here, means this is Z direction, right? So X direction, Z direction, and then finally once the renumbering is done at this level, then it goes to the next floor, which should be in Y direction. It should be in Y direction. So exactly opposite to this, I need to renumber it. Like I have to say Y, Z, and then X. I mean this order. This one, I have to say this 1, 2, 3. See, 1 means Y, Z, X, right? So that is the way to select them. I can go to the whole structure again. I'm just zooming in, select all these nodes. I go to this, I go to this modeling mode, geometry, renumbering. I go to node. I want to renumber node. I can say yes. I wanted to go to this. I need to go to this Y, X, Z, Y, now Y, Z, X. Now I'll change the numbering 100. I can just say the numbering 100. I can say accept. Okay. I can say okay. I can now get back to this front view and select all the bottommost nodes. Alt VV for renumbering. I mean for new view. Now you can just see what is the numbering here. We have 100, 101, 102. This is 113. And then 114, and then this is 169. We should not say we have 169 foundations here. So that is why we usually renumber like 1, 2, 3, 4, 5, something, so that we can recognize the number of columns based on the last number, right side, bottommost renumber number, right? So earlier we had number 70, here it is 169. It doesn't mean that we have 169 numbers, number of foundations, because it has begun from 100. It has begun from the number 100. Again, I go to this whole structure. Let me select all the nodes. I go to the geometry, renumber, nodes, yes, Y, Z, X. I wanted to renumber from 1. I can say accept, okay. I go to this front view. Let's select bottommost nodes, right click, new view, okay, and then plan view. See here, I have 70, 71, 17th one, 70th one. So I have a 70 number of columns from this. I could understand that I have a 70 number of columns for this structure, right? Now I think it is pretty clear to all of you. Now I think it is pretty clear to all of you. Is this okay? Is this clear to all of you? Can you all please confirm once, is this clear to all of you? Quick message, quick reply. Some more, some more, some more. I got only 26. Some more, some more. We have 87 participants for today. 30, 32, 35. Some more, some more. Quick, quick, quick. Quick response. Some more, some more. Everyone has to respond. There are some more left. 20 more left. 24, 20 more members. 17 members left. Some more, 15 members left. 75, 77. Some more. There are few more. 80 responses. And there are 7 more. Respond, respond, respond. We have only 87 participants, but we have got 89 responses. How is this possible? 90. Great, 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 great. Don't worry about this envelope. I will explain you this envelope. I will explain you this envelope. There are, I think, few more questions. Let me just go through them. Can we renumber the beams and columns in a similar fashion? Obviously, you can do it. Obviously, you can do it. Srinivas is saying beams design is not assigned to inclined members. Yes, we know it. We know it. We are rectifying them errors now. We are rectifying the errors one by one. I mean, warnings one by one. That's why we did not still assign that property to the member. Because saying for design of foundations, we will be using reaction for 1.5, or we should use the foundation combination maximum reaction. It's not 1.5. We have to consider all the combinations load for foundation design. Anyway, we are not talking about this foundation for this webinar. Envelope we will discuss after some time. We'll talk about flow diaphragm, not now. We'll just talk about it. I remember it. Yes, now it is done. Now we are okay with it. Now we wanted to finalize the column sizes. How can I do it? I might not be having enough knowledge on it. Then how can I do it? How can I do it for 10 member of 10 floors columns? For 10 floors columns sizes, how can I just find it out? Right? So for this, what I do is, now I wanted to know, I just wanted to know the formula for it. Like see what I need. I might know it. I think you might know. This is PU, nothing but vertical load, ultimate vertical load. Can you please stop posting questions? We will discuss about it later. So now let's proceed. Let's now proceed. Focus on it. Please focus on what is happening. Don't go beyond and just don't get back. Please stay here only. Here, all your doubts will be cleared. My sincere request is stay focused. So here we have a formula like this. So PU formula, ultimate load formula, 0.4 FCK into AC, area of concrete, plus 0.6 times of the FI, grade of steel, into area of steel that we have. Right here we have a formula like 0.4 FCK is the grade of concrete, ESC means area of concrete, 0.67, and then FI grade of steel, and then ASC area of steel that we have used it. So from this we can find out the capacity of a column, in terms of load only, in terms of load, right? For short columns it is the capacity of a load, capacity of a column formula, right? So now what I do is I wanted to find out the column size. I wanted to find out the column size. For example, let me just show you the example. Now, if I want to find out the capacity of a column for 300 by 450 mm, let me say example 300 by 450 mm. I can just say, I can go to this. If I want to find out, I can show you some of the short calculation here. See, for example, if I have a 300 by 400 column, 300 by 450 column size, right? So I have a 300 by 450. This is the breadth of the column, depth of the column, area of concrete. So breadth and depth is area of concrete. Fine. And then FCK, grade of concrete. And then FI, grade of steel. And then PT, percent of steel, we are assuming like 1.5 percentage, right? This first portion, if you can just see this, first portion, sorry. If you can just see the first portion here. If you can just see this formula carefully. So this formula, see, can you just look at here? So this formula is concrete strength and this formula is steel strength, right? This is the force that is resisted by the concrete area and this is the force that is resisted by the steel area, right? So that's why what we do is PUC, ultimate load resisted by concrete, ultimate load resisted by steel, and then PU is total load. PU is the total load. For concrete, how much it is? What is that concrete load or concrete capacity? 0.4 FCK area of concrete. 0.4 is fine. FCK is the grade of concrete. Here it is. And then, grade of concrete here is AC area of concrete. Here we have, right? So this is the amount of force that can be resisted by the concrete alone. But if I can use 1.5% of steel in it, so this is the force that can be resisted by the steel, 0.67 into Fi into ASC. 0.67 is the numeric, and then Fi, I mean numeric in the sense it is a, anyway, I don't go beyond it. So 0.67 into Fi is the area, I mean yield strength of the steel, and then ASC is nothing but area of steel. So when we say it is a 1.5 percentage, 1.5 divided by 100 into concrete area is a steel area, right? It is a steel area, right? The first one is giving us the value, the first portion is giving us the concrete capacity, and the second one is giving this steel amount of force that can be resisted by the steel. Now this is the total capacity. For example, if I increase the percentage of steel in a column, obviously column capacity or loading capacity would be increased. So what I did is intentionally I have limited, like one is 1.5% of steel and the second one is 2.5% of steel. So I did not change the column size. Column size remains same. Here 350 by 450, 300 by 450. Here also 300 by 450. Here with this 1.5% of steel. Here it is 2.5% of steel. So for the same cross section of column, if I have 1.5% of steel, this can resist up to 2000 kilonewtons. And for this, it can resist up to 2500 nearly. 2500 kilonewtons, and these two loads are ultimate loads only. So what I do is, based on some standard sizes, first I can prefer, or I can just list out the column sizes like this. I can show you the sum of the columns. So these are all the practically used columns, like 300 by 450, I can say 300 by 525, then 300 by 600. So these are all the standard column sizes. Usually we can notice it. So for these column sizes, what we have to do is, we have to keep the column size and then find out the capacity for 1.5 percentage, and then find out the capacity for 2.5 percentage also. Once we know the capacities, then we can take the reactions from the StatPro and compare these two. Compare these two. The reaction that we are getting the staad would be nothing but the capacity of a column. We can say those are the capacity of columns. So based on the reaction that we are getting, we will compare with the capacity of column, and then we group them separately. Now I can show you one of the examples here. I go to this staad, right? I go to this staad and then go to this. Now I wanted to take the reactions for it. So I will take the reactions only for this column number 1. I can take only these columns like 1, 2, 15, and then 16. I'm taking only these 4 columns. Let me separate them. Let me first separate them. I'll go to this post processing. Sorry, I think I need to reanalyze it. I think we have to reanalyze this. Let's reanalyze, no problem. Let's reanalyze it. Once we get the reactions from it, then we can just choose a kind of a column size and find out its load. I mean its capacity. It is a kind of a approximation procedure. It's a kind of a approximation procedure. Likewise, you can even prepare on your own. You can prepare a table on your own. You can prepare a table like 230 by 375, 230 by 450, 230 by 525, 230 by 600. Right? I can say okay. Post processing mode. Okay. I can say okay. Maximize it. I need to see these reactions. Click on it. Maximize this again. I go to this icon. I'll keep them. So this is what the problem with this. Sometimes the staad doesn't work on it. Okay, now let me take the reactions for this 1.5 times of this one. 1.5 times of the dead plus live. I can go to this. So these are the reactions. Like what is this value? Here I have 4,000 something else, and then 4,700. Here I have 5,000 something else, and here I have 6,000 something else, right? Here I have 4,000, 4,700, and then this one, right? 4,000 and then 4,700 something else. Let me keep it on the left side. Let me just keep it on the left side. And I keep this Excel file on the right side. Here I already have done some of the calculation for standard sizes. I can show you here. See here. So I have chosen a kind of a standard column sizes like 300 by 450, and then 300 by 370 by 525, and then 525 by 525. So these are the column sizes. See, this is one column size, second column size, third column size, fourth column size, fifth column size, this one and this one. These standard or recommended column size are already given in this PPT, which you have already noted it, right? Even if you don't know, if you have not noted this down, don't worry about it. So let me just keep you here. So this is the column size, right? So this is the column size, and this is the percentage of steel, and these are the capacities. Capacities in the sense, if it is a 1.5% of steel, so these are all the load carrying capacity of a columns. Means if I can have the same 300 by 450 column size, this can bear the load up to 2,000 kilonewtons if I can provide only 1.5% of steel. Of course, it can furtherly also resist around 2,500 also when I can increase the column size. So what I can say is I can just consider this column size when I have a loading less than 2,500. So what is this loading? This is 4,000. What is this loading? This is 4,700, and this one 6,000 yearly. This is also nearly more than 6,000. So this first column size is not feasible or not suitable. So what is next left? So I can say this one 525 by 525. 525, 525. It is from 4,000 to 5,000. So this one I can use the same column size. For this one I can use the same column size, and this one 6,000 and then 6,100. So I can say this one 600 by 600 column sizes I can consider. 600 by 600 column size I can consider for it. For these two, since the column sizes are very used, I can consider the column sizes 600 by 600 for these two. 600 by 600 for these two, right? So this is how you have to verify it. You have to verify for all the column sizes. For all the column sizes, you have to just verify those reactions with respect to the capacities. With respect to the capacities, right? Now tell me, is this clear to all of you? Can you please confirm? Is this clear to all of you? Can you please confirm? Is this clear to all of you? Super, super, very good, very good, very good, very good, very good. We are trying. It's as I had said, Syed. It is a approximate method. It's approximate method. It doesn't mean that this will be 100% passed. It doesn't mean that it's going to fail. We have to take the loads for only one combination and try to find out or fix up the column sizes. Keep this column sizes for those reactions and then run the analysis. Yeah, we may get the reactions more for other combination, but you would be very accurate. I can say you are accurate around 90%. 90% you are more accurate. We will design MIS, we will design it. What I'm saying is we are not using this, we are not designing the column here. We are trying to find out, or we are trying to fix up the column size based on only the approximate method. So we will consider only the loads. Moments anyway would be there. Those moments will be considered by the staad pro, no doubt. No doubt staad pro will consider it. But at least to give the column sizes to it, we must know the column size now based on this approximate method. Staad will consider the bending moments. Right now the way here is, I can just show you one more short way here. Short way in the sense, I now need to go to this modeling. Let's get the reactions. I wanted to get the reactions for all the combinations. I need to get the reaction for all the combinations, right? Here I have chosen only 4 columns, right? Now I wanted to get the reaction for all the columns. Then what I do is, I'm using this nodal cursor, click on this node, click twice on this node. Before that, let's go to this one. Here I have a kind of a question mark icon. Click on it, transfer all of them left side, select only 1.5 times the dead load plus live load, transfer to right side. I can say okay. It means I wanted to take the reactions only for one combination, which is 1.5 times of the dead load plus live load. Because anyway, I would not be able to see all the load combinations which are displayed on this window for 70 columns. So that is difficult for me. So that is why I just have chosen this 1.5 times of the dead load plus live load combination for it. From this, I say okay to it. I'm clicking on this node. I'm just clicking on this node. Click twice on it. I can say reactions, click twice on it, table is displayed, reactions, right? Now the reactions are here. Now the reactions are here in this table. I can click on this left side of this table, right click, copy it, right click, copy it. I go to this Excel sheet. I can paste here. I can paste all these combinations. Right? Now, I don't want to take all these bending moments, or before taking these bending moments, if you can notice it, or if you can just, if you can remember it, we had given the pinned supports. We have given the pinned support for retaining wall locations. When we ask staad pro to give the reactions, staad would be giving us the reactions for the fixed supports, and also the pinned supports. But we don't want the support. We don't want the reaction for the pinned support, right? We don't want them because we are not designing the foundations, and those are not even columns. Those are just supporting points which are acting or which are connected to the retaining wall. So I now how can I recognize or how can I find out which is the fixed support and which is the pinned support here? I can recognize that based on the bending moments. For pin to point support, bending moments would be 0. I can simply scroll this down. I can recognize that these are all the pinned supports because there are 0 bending moments. And I don't want the reactions for this. I don't want the reactions for this, right? I don't want the reactions for this. So I can select like this, scroll this down, delete them. I don't want this because these are not the columns. These are all the pinned supports which are connected to the beams and the retaining wall interface. Delete them. And these are all the reactions for this 70 columns. You can notice them here, 70 number. And also we are not considering the bending moments. So I can delete all the bending moments, Let's delete all the bending moments. And also I don't want FZ values, horizontal force. I also don't want this FX value, which is also horizontal force. I also don't want to see this load combination because we know it is only for one combination. Delete this too. Now these are the column numbers or foundation node numbers, and these are the respective load. These are the respective reactions. These are the respective reactions, right? They are the respective reactions. Now once I can know it, I can go to this. I can copy this, or I can copy like this. Control C copy. I can go to this. I can paste somewhere here. Sorry. I can paste somewhere here. For easy understanding, I can paste somewhere here. Now now I have a column sizes with respect to percentage of steel, and also these capacities or load cases, right? So what I now do is I'll go to this. I can add one row here. I'm adding one row here. I'm clicking here. I wanted to filter the reactions in this ascending order or descending order. I can just click here. I go to data. I can say filter. Sorry. I go to this point. I wanted to go for, and then I wanted to sort it out from the smallest to largest. Click on it. So this is the smallest load and this is the highest load. Bottommost is the highest load, right? I don't want this line. Delete this. I don't want this, right? So what I do is, what I do is, I can just now what I can do is, so up to 2500 kilonewtons load, I can use the same cross section, right? So now I know these are all in the order, right? So where is the 2500? Somewhere here. So up to this columns, I can use the same column size, this one. So what I do is very quickly, I can add one row here, or I can insert one row, clear this. And here I can just merge like this. I can merge like this. Please be attentive. I can merge this. I can mention the column size like 300 by 450 for this. 300 by 450. Let me click here. This one I can fill like this, right? I can fill like this, and then from 3000 to 3500, right? So this value is somewhere it is crossing 2500. However, I can consider only this column size 375 by 525 only, which can resist the load from 3000 to 3500, right? So I go to this. So from 3000 to 3500, or I can say up to 3500, I can now group it again 3500. So where is this 3500? Which is very close here only. See, here it is. I have very less columns like this only, right? I can merge this. I have very less number of columns here. So I can say it is again 375 by 525. Let me just keep it at the center. This one. Now 3500 is done up to 5000, 4000 to 5000, 525 by 525, up to 5000. So I can scroll this down. Up to 5000 means I can sometimes add this also, 5200 also, not a problem. Insert here. So I can just select all this, merge it. And this is what column size is. What is this column size? It is 525 by 525. 525 by 525. I can select it like this one, and then this one, right? Likewise, I need to add. I need to find out the column sizes. I need to find out the column sizes. Now I also need to just order them. Order like this. I can just order like this, 1, 2, 3, so on, so number. For all these numbers, I must be assigning this 300 by 450 columns, 300 by 450 column sizes, right? Yes, that is how we have to do it. Let first confirm me, is this clear to all of you? Is this clear to all of you how to do it? Is this clear to all of you how to do it? That's good. That's good. Very good. Very good. Very good. Very good. Very good. Now I just keep it on the left side, sorry, right side. I'll go to this staad file. Now I'm deleting all these properties. Now I'm deleting all these properties. Last time we just have added some property, some kind of a assumed property for running the analysis. That's it, right? Thank you so much for your great response. So I select like this. Let me delete them. Delete all these properties. Now I don't want these properties. Now let's add them. Now let's add the properties here. Please don't post any questions for now. Right now the column sizes are here like this. Define rectangle, column depth is 450 and then width is 0.3. Add it. What is the next column size? Then 375 is the width and then 525 is the depth. Add it. What is the next column size? 525 by 525. Add it. And then 600 by 600. Add it. And then 675 by 675. Add it. And then 750 by 750. Add it. And then 900 by 900. Add it. Say close. These are all the properties for the columns. Now I go to this select, beans palette to Y direction, new view, okay, right? Now I have only this one, and I have only these columns in this picture. I'll take the bottommost columns. I'll take only the bottommost columns. Let me turn off. I'll take only the bottommost nodes, bottommost columns here. Alt VV. Right? So now I'm here. Now I'm here, right? So let me keep it on the left side. Let me keep it on the left side. And now these are all the numbers, 13, 14, 20, something else, right? I go to this property, 13, 14, 20, 21. Let me turn on this number, shift N, numbers. So 13, 14, where is the 13 and 14? Here is the 14 number. I can say 14 and then 13 also. 13, 14. I have to select the first property here. 13 and then 14. Assign it. And then 20 and then 21. 20 and 21 means here only. 20 and then 21 here only. And then 44, 57. 44, then 57, these two. And then 57, 58, 59, 60. 57 over now. 58, 59, 60. 58, 59, 60. 58, 59, 60. And then 62, 63, 64, 65, 67, 68, 69, 70. So from 62, I can say 60 to 70. So it is 60, 61, 62, something else. Select this, select this, this, and this one also, right? So now I understand, since these columns are exterior columns which are attracting less loads, which would be requiring only this column. I can also strongly say we can add these two columns also with the same property. You can also add the property of this property to these two columns also, because we are limiting the percentage till only 2.5. If you can change the percentage till beyond 2.5, if you can consider around 3%, yes, you can use the same column size and you can fit it, right? So I'm using these two columns also with the same property. Let's assign, right? So from this, it is very clear that we have to assign all these external columns with the same property. Now I go to this whole structure. Let's select the beams parallel to y direction, all to VV, right? I go to this plan view, right? Now I select all these columns fully. I can select like this. I can select like this. Assign, yes. Now these properties are assigned. The properties are assigned to this structure now. Yes, it is done. Excel sheet also we have node numbers only. We don't have beam numbers. We did not talk about any beam number so far, Mr. Bhowmik. It is a node number. I am referring the bottommost node number. I am referring the bottommost node number to recognize the column location. Right, this is done. Likewise, I need to select the remaining things. Likewise, I need to add this one also, remaining things like 3000 means 26, 27, and then 43. Now what I do is 26, 27, then 43, 56 also. I think these two also might be 26. Let me turn on. Where is the 26? If I want to see the node numbers, here, if I want to see the node numbers 26, 27, 43, 56, I can go to select. Can you please note this down? I can go to select. I can go to this list. I can go to the nodes. Here I type the node numbers 26, 27, 43, 56. From this I can recognize it. So where are those numbers? So here those numbers. These two are anyway assigned with the previous property, and these ones have to be assigned with this property, right? So this is 43 and then 56, right? So what I do is not only I'll add this property for these two columns, I also will continue adding to these remaining two columns also. So next step property is this one. I will add the property to this, and then this, and then this, and then this, right? These are all the columns which are extended up to this basement level, means ground level only. These are all extended up to the ground level slab. I can say assign, yes. These are also assigned with the property, right? Done. Now I can go to this 1, 2, so on, so on, so. Select all of them, copy it. I go to select, by list, nodes, I can paste them. See, sorry, I have to paste all these numbers like 1, 2, 17, 18, 19, 24, 25, 28, 29, 36, 37. Control C, copy it, right? See, select them now. So these are all the columns. This one, so these two columns, and then the remaining these columns also. Now I go to this third property. Now I go to this third property. I also will prefer to add this property. No, I don't do this. I'll go to these properties, these ones. I will assign this property to this. So I'll select like this one, and then I'll select this one, this one, this one, and then I think this one. Sorry. Once again, let me select by list node numbers. I'll paste here, select them. So 1, 2, 3, 5, 6, right? So I select like this. So this one, I select like this one, this one, this one, this one with this property, right? And of course, here also I have two more columns that I can assign with this. I can say yes, find again, select by list nodes, paste here. I can say okay. So I have to assign this property to these columns also. We can assign them. Done. Right? This is also done. Now I can go to this 5, 6, 11, something else. Now I go to this, select by list node numbers. Now I will type this 5, 6, 11, 12, 15, 16, 22, 23, 34. Sorry. Select by list node numbers. Yes. So 5, 6, 11, 12, 15, 16, 22, 23, 34, 42, 48, 49. Copy them first. Select. So where are those? I can recognize. See, this one all selected, this one. So I go to this now, this property. I'm now selecting these ones. See, this one, this one. Let me assign it first. I go to this again, select by list. Sorry. I go to this select by list nodes here, paste it. I can say okay. So these are all assigned. Here for this column, these two columns. I have to select this column. I have to select this column. I have to select this column. Assign yes. Now I'm done with this. Are we missing anything? Now once again just select it. I'll go to this select by list node numbers. I paste here. Let's check it. Use these arrows. Yes, these are done. So I have to now assign this property to this front columns also. Here I have these two columns, and also this one for which we have already assigned the property. So I'll go to this plan view. I have to assign this property to these two columns also, assign them. Yes, now done. Now we are done with this, right? Now we are done this. Now I need to go to this 675 and then 675. Before I'm going to assign the property to it, before I'm going to assign this property, what I now do is to make the view very clear, so what I do is I'll select beams. I'll go to this select, and then I'll go to this missing attributes. I wanted to select the members which are not assigned with the property, so that would be easy for me to recognize it. So I'm going to this select by missing attributes. I can select any one of them, and these are all the columns which are not yet assigned with the property. I can say Alt VV, right? Now I can look for these node numbers. It is easy for me to recognize it now, because last time we had columns which are already assigned with the property, and remaining columns which are not assigned with the property. That is difficult to recognize them. So now we are done with this. Now we have to go to this yes, 3, 32, 33, something else. So I go to this select by list nodes, select here, then 3, 32, 33, 45, 53. Copy, select them. See, now it is easy. This one, this one, this one, this ones, right? I can say, I can now go to this plan view. I can drag a box like this. If I miss something, then I can get back to this by list nodes, paste this one. See, now let's select like this. 1, 2, 3, 4, and then this one. This one, this one. I mean, I can see clearly these two, this one, and then this one. Assign, yes. This is also now done. Now I have to go to this next property, this one, right? I'll go to this, assign, select. By missing attribute, I can say property, new view. These members are not assigned with the property. I'm using arrows here. Now I have this list of node numbers. I'll go to select, by list, nodes, okay, 10, 30, 35, 41, 46, 50, 51, 52, 54, 55. Copy them, yes. So these are all the columns which require 750 by 750. See this? Right? I can also, yes, see this, almost this line, complete line except this. So I assign this property even for this column also. And then here and then here. So I go like this, right? I select like this one, this one, this one, this one, this one, this two, and I think last one also. Assign this property, say okay to it, say okay to it. Again, I'll go to select, by list, nodes, I can paste here. I can say okay. So what else? Yes, I have to assign this property to these two columns. Select this, assign, done. And it is sure that the remaining columns are requiring this. However, I'm going to consider the same columns as even these two also, since these are very closer. We are trying with it. If it fails, then okay, then we will see it. And this is the column size, which has to be assigned for the remaining columns, So I can go to this also. I'll assign this 750 to this column also. I can say assign. I'll go to this 900 by 900. Select, by missing attributes. All these columns must be assigned with this property. Done. Congratulations. Congratulations. This much hard work we need to do in actual condition when we are designing 10 floors building. Don't ever think that software does everything. Software really don't do anything. Unless we know what we have to do it, we can design them, right? Now what I do is just to verify the number of warnings or number of warnings. Last time we had warnings wide 501, right? 501 warnings we had, right? So now what I do is I'll go to this and just for this plinth level, let me clear you. Plinth level, usually we for plinth level I can consider only 500 length, 500 or 550 depth of the beam. I'll let you know how it is. Define. I'm considering this a plinth beam depth as 500 or 550 also, it's fine. And then 230 is the width. I'm considering the same thing for, yes, all the plinth beams. I'll let you know why it is. Right? Now, just for this sake, I'm considering some numbering. I'm just considering some random beam size here. So I'm considering the beam size like 300 by, I can say 750 by 300. Now assigning this to all the members or all the beams. Just to verify the number of warnings, we will work out how we can choose the beam sizes also. I'm just using some random size now for columns. Okay, we are ready, we are okay with it, because I wanted to just let you know how many number of warnings we could avoid by freezing the column sizes. Now I'm running the analysis by pressing F9. Say yes. How many warnings we have got so far? 3 warnings. Let's wait. Let's wait the remaining warnings. Wow, wonderful, wonderful. See how many warnings we could avoid? Now it's a time to clap. We have got 14 warnings. From 501 warning to we have got 14 warnings. Now it's a time to clap. See this? Yes, yes, now it's a clap. Time for clap. So that is what original way of designing a structure. This is how you have to learn it. Great, great. Geetanjali, then Vishal, and then Gunjan, Manikandan. Thank you so much. Manikandan, Avinash. See where we were? We were exactly at 501 warnings. Now we are at 14 warnings. We are not near to pass, we passed. So that is where we need to use our theoretical knowledge. That is how we have to use a software. It doesn't mean that we just can go through a kind of a, using these tools. Here we have beam option, column option, this and that. It's not really easy to learn designs. Trust me, it's not really easy to learn the designs. And I can also very strongly say it is easy to learn the designs from an experienced person. But if you can try to learn from a person who does not have a same background, same engineering background and same experience, then it is a waste of time, waste of money, waste of energy also for spending, for learning it. Now, is this clear? Is this clear? But I must be getting some more responses. I must be getting responses, more responses. That's great, great. Thank you, Chirayu. Thank you so much for Sai Rupesh. And then Sai Rupesh is saying yes, 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 yes. Thank you, Wadid. Yes, Shailesh, you are correct. People usually do not share the entire information or entire knowledge, how to do it. And if you can verify it, this is the first time that I was explaining you for this structure, because it's now time to learn that concept. Because many people had a doubt how to fix up the column size, how to fix up the column size. This is how to fix up the column size. Right, fantastic. Yeah, now that's what I'm going to say now. That's what I'm going to say now. So is this okay if I can continue for 15 minutes more? It's now 8:55 or something else. Can I continue for 15 minutes more? Then we can close the fixing the member sizes for beams. It's easy for member size, beam sizes. So that with this we can freeze the model. Then that would be easy for us to start a fresh topic tomorrow. Can I continue only for 10 to 15 minutes? If anyone does not have enough time, they can go ahead. I can send you the link. But kindly give me only 15 minutes time. Yes, so tomorrow is a Sunday, but still we have class. We still have class because I don't want to extend it for too long. I don't want to extend our webinar for too long. We'll have a class tomorrow. It's a kind of a learning that we are studying maybe a 10th standard or something, 8th standard, where we had put more efforts for passing examination. Yes, let me continue it. Let me continue it. See, usually for plinth beams, we don't have a slab. When we don't have a slab, you can give a kind of a I'm going to show you. I'm going to show you the column sizes here. These are all the columns, or I can just show you bottommost nodes all to VV. Yes, see this? They're all the column to column. I mean, these are all the columns. So what is the maximum length here? This one, 9 meters. Here again, 9 meters. This one, yes, it's a 6.5 meters. Very technically speaking, in the horizontal directions, we have a longer spans. In this horizontal, I mean, this transverse directions, in the longer direction, we have a maximum span like 9 meters, 9 meters, something else. In this transverse directions, we have 6 meters maximum, 6 meters maximum. So what I can suggest is, we have a thumb rule for fixing of the beam size. Fixing of the beam size, that is L by 10. L by 10 is the thumb rule that we can use it. L by 10 is the thumb rule that we can use it, right? But L by 10 thumb rule is not really suitable in the case of the plinth beam sizes, because in the case of the plinth beams, we don't have any kind of extra load. In the case of the plinth beams, we'll have only wall load if walls are there. And we know it is a cellar. Definitely these plinth beams are not even resisting walls. There are not even there are not even walls. We will work hard. Probably we'll have a class in the evening. We'll have a class in the evening. Don't worry about it. Please focus on it. We have only 15 minutes. I don't want to take further time. All right. So now it is very clear that we have a span of 9.2 meters in the horizontal directions, and in this direction only 6.5 meters. And we know L by 10 is the thumb rule. L by 10 is the thumb rule. So when I use L by 10 thumb rule, technically speaking, I must be using 9.2 meters by 10. That is 900 depth of the beam. 900 depth of the beam, right? Can you stop posting questions, please, for some time? In horizontal directions, length of the member is 9.2 meters, and then length of distance between two columns is 9.2 meters, and in width direction we have a 6.5 meters. Thumb rule for the beam depth fixation is L by 10, L by 10, right? So when I say L by 10, here 9.2, 9.2 by 10, 920 mm. 920 mm or 0.92 meters, right? So which thumb rule can be used for the floor beams, not for the plinth beams? Because in the case of the plinth beams will not resist much loads, because in the plinth level we might be having only wall loads. Sometimes we don't even have a wall loads also. Then using this plinth, using this concept of L by 10 thumb rule would not be so effective. Would not be so effective, right? So that's why what I do now is I'll go to this plinth beams now. I'll select this plinth beams now. I select this plinth beams now. Alt VV, right? So what I do is, for all these cases, like, yes, I am going to now delete. Either I can give a standard size of 500. I can give in the transverse direction 500, and then lateral direction I can give 600. I'm defining one more property, rectangle. Depth is 600 for plinth beam and 300 width, right? This property I'm using for few beams. I'm using for these beams only. This one, these ones, because this length is very high. These ones, these ones, these ones. That's it. So since the length of these members are very high, I'm using this as 600 by 300. 600 is the depth, 300 is the width. I can say assign. That's it. And the remaining members are 230 by 500. That is more than sufficient. That is more than sufficient. And we also don't want to see for these members, when you can just see these members, these column to column distance is very less. You can even consider only 350 mm or 375 mm depth of the beam. But don't go for multiple sizes of beam sizes. Multiple beam sizes, because it is difficult for them to shutter it or to fix this formwork. So you can just go for hardly 2 to 3 types of the member sizes in the case of the plinth beam. Don't go beyond it. Now the plinth beams are done. I'll go to this floor level, right? I'll now go to this floor level. This one. Even here also I'll have a same kind of thing. Sorry. Anyways, no problem. Even here also we have a same span. We know that we have a same span here. So what I do is, I'll go to this these ones in the horizontal directions. 9.2 meters is the maximum span. So I go to this define. 9.2 now. I'll go to this 9.2. 9.2 means 900. So I don't anyway keep 900. I'll keep 353, sorry, 0.75 depth of the beam. And I'll consider the width of the beam like, I can consider the width of the beam like 375. 375 because I don't want to consider 900 mm depth of the beam. When I say 900, 3 feet depth, 3 feet depth. So we have a floor to floor height of 11 feet. 11 feet minus 3 feet, it's 8 feet only. It's a 8 feet clear dimension. So which is why I'll consider the depth of the beam as maximum 750 and I'm increasing the beam width as 375. I'll consider this. I'll select this. I'll consider this 375 by 700 for the longer beams, right? For longer beams, I can say, yes, these beams, I can say all these horizontal members. So let me go to this one. Let me take this and let me take this also. So yes, I'll take this one, this one, this one, this one, and then this one, this one, this one, this one, this one, this one, and then this one. I'll take again this one, this one, this one, this one. Take this one, 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 this one. Maximum member sizes. I mean member lengths. Right, remaining all are all right. Remaining all are all right. I can assign this. And again, I'll go to this. I'll go to this remaining beam depths. I can consider 650 by 300. 650 by 300. I can consider 650 by 300. Assign. So remaining are 6.5 meters only hardly. So I'll consider this remaining 650. And I assign this property. In fact, not really required to assign every member. But in this case, I'm assigning it. In this case, I'm assigning it. I'll go to this select by missing attribute. I can say yes, assign, done. I'm assigning remaining properties with 650 by 300. Very technically speaking, I can reduce the member sizes for this level, and then this level. However, we are proceeding with the same beam depth, which would be the easy for construction. I'll go here. I'll go like this. The same thing I must be doing here. And also I must be selecting here, and I'll be selecting the bottommost columns just for recognizing the member sizes, right? I can now select again 750 here. I can select this. I can select remaining this 1, 2, 3, this 1, 2, 3, this 1, 2, 1, 2, 1, 2. I can say 1, 2, 1, this one, not this, 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 this. Right? Yes, I can say yes. Right? I can now assign this property for remaining all the members. As select by missing attribute, yes, assign yes. Right? So likewise, I have to assign the property for remaining floors also. Likewise, I need to assign the property for remaining floors also. I go to this Alt VV, yes, define rectangle 750, and then this is 375, and then 650. I can keep only 300. I'll select this one. I'll select this. Select missing attribute, assign, yes. I go to whole structure. I go to this one again, this one, sorry, this one, these ones, these ones, Select by inverse beam selection. Yes, sorry. Select missing attribute. I can say yes. This one. I can select only these members. I can select this floor levels. Floor levels only. Alt VV. I must be doing the same thing for here. Define, or otherwise I know I have this one. I select this one. This. Now lastly, I can select this small property, define rectangle. This is 450 depth and this is a 300. For remaining mid landing beams or floor beams, whatever it is, I can say select. By missing attributes, I can say assign. Yes, okay. Now we are okay with it. Now we are okay with it. Now once again run the analysis. This time we might get more warnings or less warnings. But this is now the way for checking it. Now I'm running the analysis. Now running the analysis. We might get more than 14 warnings or we might not get those warnings. Let's check it. Okay, we are happy. We still have the same number of warnings. Now it's time to go to those warnings and find out the reason. I have 6 minutes more time. I wanted to leave you by 9:15. It's now 9:08. Let me fix it in the next 2 minutes. Yeah, these are all the column numbers. Can you all please note down those column numbers which are still failing? Because last day we did not strictly follow what we planned for. And let me just check this. What is this column number? So it's number 18. Can you please note down 18? Sorry, yeah, it's number 18. Click on it. What is this number? Number 32. Can you please note down 18, 32, or otherwise I can keep somewhere here. Let me just keep right side. This one, close this. So what is this number? First one here is what is this number? 18. 18, and then second one is yes 32, and then third one is 34, fourth one is 36, fifth one is 43, seventh one is 211, and this one eighth one is 217. In fact, last time we did not observe, the columns got failed. 230, and what is this? Column number 3834. So these are all the columns that are getting failed. Now we will relook into it. We will relook into this, and we also will note. Let's check this member numbers also. Member numbers. What is this number? Beam numbers. Here we have a beam number also. Let's note down beam numbers also. What is the beam number? 381. This one 1253. What is this one? 1256. It's 1259. Yes. Now I go to this working, select by list. Sorry, select beams parallel to Y. Now we select the list beams. Beams does not run beam, it is a member. For 18, 32, or I can copy it. I can copy and paste here. So if you know it, so there are the members still getting failed at extreme down. There are the numbers which are getting failed extreme down. Don't worry about the extreme down. Extreme down, don't worry about it. So these are the members which are still getting failed. Right? So these are the members. So I go to this property. If the members are getting failed extreme down, don't worry about it. But if the members are getting failed like this, yes, you can. Because extreme down, we can keep pedestal. We can keep pedestal for extreme down. So I'm ignoring this one, ignoring this one. I'm also ignoring this one. I don't ignore these two. Ignore this. No, I don't ignore this two. I can ignore this. I can, yes. So did you understand it? Did you understand? So bottommost nodes, bottommost columns, if those are getting failed, don't worry about it. Because we keep the pedestal for it. So now I can just go to this property, relook into these properties, and these are the properties members. I guess. See here, R5 is not sufficient for this R5. So this is the R5, which is not sufficient for it. So for this, it is not sufficient. And then, how about other members? If it is not sufficient, R5 is not sufficient, then I can consider next level. For this, I can consider next level, this one, R6. I can consider this, assign, yes. And then I go to this select, by list, beams, paste here, search for them. Sorry, this one is done. Yeah, this one R10. Here we have R10. I go to this, yes. Even R10 is not sufficient. I mean 900 by 900 is also not sufficient. 900 by 900 is also not sufficient. Fine, no problem. So anyway, I don't change that. By list, beams, paste. So this is done. How about this? So these are all. Here is R6 and this is R9. R6 can be changed to R7. R6 can be changed to R7, and this is R9, right? R6 to R7. This I can consider this R7. Assign. R9 can be R10. R9 can be R10 up to this one. I can consider this. And then again I go to this select, by list, beams, paste this and find out where those are. This one is, what is this value? So it is extreme down, I don't consider it. Because anyway, extreme down will have a kind of a pedestal which will be passing. I don't consider it. This one is R6, it is considered. R10, I don't do go beyond it. Any more column? Even here also I have R9. I don't change this. Let us keep R9 only. This is changed. Yes, this is now changed. And now I go to this whole structure. Let me find out even these member numbers. Control C, copy it. I'll go to this select beam numbers, paste them, and find out where those are. See this? Only these member numbers are failing. You can change these member sizes. And let me find out where those are. I'm using arrows here. I'm just using arrows and trying to find out where those are located. Here those are. So these sizes are not sufficient. Yes, no problem. I can go here. I can find out where those are. So this is the level. This is the level. I can select them all to BV. Yes. Now I go to this, select by list beam numbers. I can paste here. Yeah, these numbers are getting failed. So what are these member sizes? I'll go to this member size. Let me check that member size. Sorry. So let me check those number size. I'll go to select by list beams, paste here, find it out. So what is this size? Sorry, R16. What is R16 here? This one is also not sufficient. Even this one is also not sufficient. So I can make slight change to it. R16. I don't think I need to change it. That would be definitely sufficient. But still, I can add another property for it. I can add another property. I can say 750, and then I can say it's a 650, no? It's 650, and then 725. I can consider 725 next level of beam. I can say this 300. Right now, I go to this select by list. This one, all this, yes. Assign this property to them. Now we can now analyze this. F9. Now let's look into this member failures. It is not really easy to control the warnings and errors. It is a very difficult task because that is purely depending on the amount of the knowledge we have and how when we have to recognize how those numbers are getting paid. Out of 7 warnings, we are going to ignore 4 warnings. As you know, that bottommost columns which are getting failed will not be redesigned. We don't do that. Oh, it's still 14. So only 2 warnings are controlled. Output file, okay. Relook into this. Yes, we don't consider this 1, 2, 3, 4. We don't consider. We don't really look into this. We have to focus only on this. So 4, and then this one more number, new number it might be. Let's check this number 1256. So this might be the same one. 1256 is here. 1, 2, 3, 4, and then 2. 1, 2, 3, 4. So what is this number? 381. 381. I'll keep this 381 as here. And this one is what is the second number? 695. Odd number 1003. Fourth number 1252. This one 1256. This one 1259. I'll select these numbers. I'll again get back to this. Select by list beams, find them out, say OK. I'll now change the width also, the width of those beams also from 375. Or otherwise I can say this one. I can select the same property. I can select this by list, this one. I can go to this by list, this one. Now I'm assigning this a maximum property to them also. Now run the analysis. There might be some variation in the sense beams variation, beam depth variation, width variation. Don't worry about it. I'm going to stop it in next 2 minutes. Thank you. I'm going to stop it in next 2 minutes. We are still getting the same 12 warnings. We are getting the same 12 warnings. Anyway, I'll just rectify them. I'll send it to you. No problem. I need to just change this this one. I have to change the member size and I can send you. No problem. I don't want to extend it further. I'm going to now pause it. Stop recording.